Hey, Mr. Simone here. Today's video is all about determining whether a relationship is a function. In math, there are many different types of relationships. Some are functional relationships and some are not. To be a functional relationship, the number one thing to remember is that every input, every x value that you have, must be mapped to one and only one output. If an input has multiple outputs, it is not considered a functional relationship. So what we have in front of you here is a few different examples of relationships. The first set of three are all what are considered mapping diagrams. And in each situation, your inputs, which are your x values, are being mapped to their specific outputs. And the goal is to see if it is a functional relationship, if there is a one-to-one relationship. So with the first example, you'll notice that all of our inputs from -6, -2, 1, and 3, all of our inputs are mapped to one and only one output, so that this is, yes, considered a function. All right. I do have students ask me, is the one on the input the same as the one on the output? And the truth is that they have the same value, but if one is an input and one is an output, they're not considered the same. Something that can be a little bit tricky with some students when they're seeing functions. For number 2, you'll notice that 5 is with 4, 2 is with 1, 0 is with -2, and -3 is with 1. As long as your x values are unique, even if two inputs have the same output, that is okay. That's still considered a functional relationship. So this is true. With number 3, you'll notice that our input of 4 is being, its output is actually 2 and 5 at the same time. This is not a functional relationship because, again, it doesn't maintain that one-to-one relationship. All right, so 4 makes this not a function. So this is a no. Other ways to see relationships are in tables. The same thing, all your x values, those are your inputs, your y values are your outputs, and each input is mapped to an output. When you look at this, example, you'll notice that all my x values are not repeating, they're unique. So this is, yes, a function. With number 5, you'll see that there is, in your x column, you'll see that there is a 5 here. 5 is mapped with -3 and 5 is mapped with 2, which means that 5 is being mapped to both of those values. Your input of 5 cannot have multiple outputs. Now some kids will say, well, Mr. Simone, what happens if, over here 5 is mapped to 2 and then later on 5 is also mapped to 2? That is, yes, it's considered a functional relationship. What you have here is not a function, so this is no. All right. And then number 6, if you look here, you have 3 is mapped to 7 and 3 is mapped to 5. Again, this is not a function. This is not a functional relationship, so that's a no. All right, so these are just some examples of ways to see relationships, mapping diagrams, and tables. What you have next, these are some other examples of how relationships are given. For number 7 and 8, you have sets of relationships. These are where you have ordered pairs where each input is mapped to an output. In this example, 2 is with 5, so 2 is our input, 5 is our output. So if you notice, all of our x values, you've got 2, you've got 4, 3, 5, and -2. They're all unique. Yes, 2 is with 5 and -2 is with 5, but our inputs are unique, so this is yes, this is a function. Same thing over here, if you look, you'll notice that 6, -4, 5, 4, and 6, those are all our inputs. And you'll see that with 6, 6 is mapped to -1, and 6 is mapped to 5. So can that be a function? The answer is no. Okay, 6 cannot have two outputs for the same input, so this is not a function. Other ways to see relationships are in equations. And the number one thing is we want to make sure that our x values are actually in some ways seen, and every x value must have one y value. Normally with equations, if you notice that y is squared, it usually means that there's two possibilities. So in some cases you want to think of an input-output situation. And a lot of times what's good with equations like 9 or 10 is you want to choose any x value and see if you get a different y value. It should be a one-to-one relationship. This is, yes, a function. This is actually a linear function. And over here, you'll notice that there is no x, which means that no matter what x is, it'll have the same output of 11. So this is also considered, yes, a function. This will actually be a linear function that creates a line that's horizontal. The last way to see functional relationships that we'll talk about in class is through actual graphs. We have some continuous graphs where there's no holes or gaps. We have some discrete graphs which are distinct points. And the one way to test this is using what's called the vertical line test. I draw in a vertical line which represents my input, and I want to see how many times does it hit the graph. If it hits more than one place, then it's not a function. So no matter where you choose to draw your inputs, your vertical lines, if each vertical line only hits the graph in one specific place, it is considered, yes, a function. With number 12, if you notice, if we draw vertical lines through this discrete function, which are distinct points, you'll notice that right here, that input, which potentially could be 2, the input of 2 has 2 different outputs. This defines it to be not a function. It is a relationship, but it's not a function. And lastly, if you look over here at our continuous graph kind of arcs this way. And again, if you draw a vertical line as an input, you'll notice it has multiple outputs. This again defines that it is not a function. So again, there are many relationships in math. One of the ones we look for to be a function is a one-to-one relationship. Every input must only have one output. I hope this helps, and you can continue to to watch videos, and hopefully this helps. All right, we'll see you later.